Hello everybody. Okay, let's now get started with network scenarios which are wireless in nature. So we are now focusing on wireless networks. So far we had been using wired, so we'll be using wireless. So which will mean in our physical layer, so physical layer will be wireless. That is basically radio waves. Radio frequency waves or signals will be used in the physical layer. And then because of this, we'll have the link layer also, which will have to change a little bit. And here we have a couple of combinations. So we could be using Wi-Fi, or we could be using Bluetooth, or we could be using sensor MAC also, SMAC. In fact, sometimes you will also see the numbers. Wi-Fi, we know it is 802, IEEE 802.11. Bluetooth, likewise, it is given by IEEE 802.15. I think it is 4. And yeah, these are IEEE standards. Okay. And then in the network layer, the changes will be, or the routing protocols that will be used. Basically, AODV is one, another is DSR, and the third one is DSDV. These are the routing protocols. So what we'll do is next set of experiments, for example 8 that we are starting off now, we are focusing on using AODV and DSR. That is, we'll use one setup where we'll use this routing protocol, and of course we'll use Wi-Fi at the link layer. This will be 8th experiment that we'll do, and likewise the second part of 8 will use DSR. That is, we'll use this instead of AODV, we'll replace it with DSR and still use Wi-Fi itself in the link layer. And then in the 9th experiment, what we'll do is we'll just change the routing protocol to DSDV, so that this is yet to follow. And likewise in 10th experiment, what we'll do is we will use AODV in the 10th experiment, and we'll try to, now in the 10th experiment we'll try to change the link layers. We'll just go ahead with Wi-Fi itself. And the other thing we'll do is we'll change the Wi-Fi to Bluetooth and see how the performance will be in 10th. And finally in the 11th experiment, what we'll do is we'll retain AODV at the network layer, and then use sensor MAC in the link layer. So this will be the 11th experiment. In fact, all the experiments from 8 to 11 now, 8, 9, 10, 11, 4 experiments. So what we'll be doing is we'll be just using various combinations of the network layer, that is various combinations of the routing protocols, and we'll also see how they will perform if the link layer is changed, if link layer is Wi-Fi, Bluetooth and SMAC. So this is what we'll cover in 8 to 11 experiments. And note, the physical layer will now be a wireless scenario. Okay. Having said that, now let's quickly get into the 8th experiment. So in the 8th experiment, we want to build a wireless network. So let's get to our manual. What does our manual say? Our manual says, since 8th and 9th are related, we just want to go ahead with wireless with Wi-Fi in the data link layer, and we just want to use the different routing protocols. We'll use the same network for both 8th and 9th. Fine. So we'll now go ahead. This is the network that has been given to us. This is what we need to construct. Note now that the nodes N0, N1, N2, most of them it makes sense to us. Some of them are new. For example, what it is saying is, it is saying now N0 node, in fact you can see there is no direct link between N0 and N1, or the circle indicates that they are now having some radio, they are using the radio frequency as the means of propagation. So there is no direct link over here. So only if they are within the range, N0 and N1 are within the range of each other, there will be radio propagations, or there will be a link setup. That is one point. And the other things to note, or the common things that we can recognize immediately, okay, there seems to be a TCP here at N0, there seems to be a sync at N1, fine. And there seems to be a FTP server, that is also fine. And start time, packet size, new reno, simulation times, and all these things we understand. Some of the new things that have been given, for example, N0 has been said that this is the X coordinate, Y coordinate, and Z coordinates. And likewise, N1, the coordinates have been given, N2, the coordinates have been given. Which means that these nodes, since they are wireless, they could be moving as well. Unlike the previous scenario, they were not moving in the wired scenario, whereas here they could be moving. And those specifications also have been given, saying that initially they are at this location, whereas at 10th second, they start moving towards a new destination whose X and Y coordinates have been given, and it's moving from this initial position to this position with a velocity of, or a speed of 3 km it is saying. And then after that again, it is at 110th second, again it's moving to a new destination given by these coordinates and with a velocity of this. That means this guy is now a mobile node. So likewise this node also, initially this is the coordinates, and then at 15th second it is moving to a new destination with a velocity with it, and N2 seems to be stationary. He is not moving, whatever initial locations are there. Good. So this is what it comes out from here. Now let's get into, let's minimize this, let's keep it to one side. Okay, and then let's get into our Ubuntu. Let's maximize this. Yeah, let's maximize this. We are here. We are into our Ubuntu terminal, and let's start our NSG. Let's start it with ampersand. Let that go into background. Okay, we have our the usual NSG. The difference now is the scenario that we want to choose. Now we want to choose a wireless scenario. So we'll choose a wireless scenario, and nodes as usual we were told one node, N0, N1 and N3. Fine. One thing we could have done is, since N0, N1 and N2, their initial location was told, we could have actually chosen on the canvas. Initially it was said 5, 5 and 0. So you can see that here you can see the location being specified wherever we take the mouse. So we could have gone to that 5, 5 and place a node over there. That's one way. But you can imagine getting 5, 5 is pretty difficult. I mean, we'll have to zoom out and then place it at the exact location based on these readings. It becomes tough. So what we'll do is, the other procedure we'll follow is, we'll keep it wherever we want now, like it has been placed here. And then we'll generate the TCL file. And inside the TCL file, let's go ahead and modify the initial locations to 5 and 5. So, okay, as per our convenience, we just place them over here. Good. Then after that, we are supposed to talk about the movement of this. So what we'll do is, we'll highlight this. Okay, we have the manual now. So let's now minimize this or keep it to one side, right? And then we have the manual here, or the diagram here. So okay, the diagram says at 10th second, and it needs to move to a new destination, and destination is given by 250, 250. That is what it is mentioning here, and it should move with a speed of 3. Okay, we add it, and then again at 110th second, it is supposed to move at a new destination, which is 480 and 300. Okay, and it needs to move with a velocity of, or speed of, 5 kilometers per second. Sorry, hour. 5 kilometers per hour. So we have defined whatever I have been given here. Good. And then again, this is node 1. Node 1 also is mobile. So node 1 is also mobile. So we'll right click it. We get the waypoint. We choose that. We say start time is 15. Destination, new destination 45. And 285. And the speed is 5 kilometers per hour. We add this. We say done. Good. So you have defined the mobilities of both of the nodes. Good. And then we'll get to the agent. Agent, we want TCP new reno. TCP new reno. Packet size, okay, default packet size. And we want this new reno to be on N0. And then we want the sync to be on N1. And we are supposed to connect these two. And then we are supposed to have a FTP. Okay, let's get to the application. FTP. When does it need to start? Okay, it needs to start at 12 seconds. Stop at 150 seconds. Okay, so we have that FTP. Then we get to parameters. Note that since we have made the FTP to run till 150, so we want the simulation to be little bit more than that. So either it should be 150 or greater than that. We'll keep it as 160. Okay, and then let's name the trace file. We are doing experiment. We are doing experiment 08, and we want to do with AODV. Okay, so that okay, we'll name the files with the routing protocol that we want to use, and this also experiment 08-AODV.nab. We'll set it as default. Note here, since it is a wireless scenario, we got few additional tabs which we hadn't seen before. So let's get here and see what these are. Yes, we can see that all this channel, wireless, there are lots of options that we could have changed. But as of now, we'll not change anything. We just want to change the routing protocol alone. Other things to observe are that physical type, wireless physical layer, and look at the MAC. MAC is using 802.11. That means we are using Wi-Fi now. We'll not change it. We'll keep it to Wi-Fi itself. And what we'll do is we'll only change the routing protocol. And we want to do AODV first. So we'll just choose a drop down and choose AODV. Okay. And we'll say rest all of them are fine. We won't change anything. We'll say done. Sorry, before I should have shown you the channel also. Okay. Look at the channel. Gain, transmitter gain, receiver gain, frequencies, bandwidth, and all those things are there. Lots of details that the network simulator allows us, but we won't change any of this. We'll keep them as default as it is, and then we'll say done. Okay, we're done with the parameters. Then we'll get to the TCL. Good, we have got the TCL. We'll save the TCL now. We'll go to code or home directory, and then we'll save it as experiment 08 AODV.tcl. We'll save this, and then we'll go to our terminal, and then we have got our file. Yeah, you can see that it is experiment 8 AODV.tcl. We'll open it using gedit, or you can have use a file manager as well. Anyway, we are doing experiment 08 AODV, and we'll open it using gedit. And here all those things that you have specified. Look at this. This was the routing protocol that we specified, and it has come here. And few other things, X and Y. In fact, this canvas size, we want it to be 500 into 400. In fact, we could have, this canvas is bigger than the 500 into 400. We could have left it with this, but anyway, just to show how we can modify it. X value is 500 canvas size, and the Y value is 400. Okay. Some of the students make this mistake. What they do is FTP, they make it run till 150 seconds, whereas the simulation time, they'll just leave it by default, which was 10. And because of that, they'll not see the animations happening. Some students get stuck over there. But remember, the simulation time also should be extended beyond the application's time. So we have made it beyond application time. That is one point to note. Fine. And then routing protocol. And then we are supposed to open a file to save our congestion window size like we had been doing previously. So let's define it here. Set congestion window file handle, that is the handle, and we want to open experiment 08 and this was AODV. Remember the convention we have been using. All congestion window data should be ending with -cwnd.dat, because only then our GNU plot script that we had written, that will search for files which have this extension, any name, but should end with this part. Only then our GNU plot script will pick it up. That's the reason we are using this. Okay. Then the other thing, we hadn't set the initial values. So yes, here we are. So we should set the initial values now. 3 nodes are defined, and we know node 0 should be starting with x value as 5, initial value as this also as 5, 5 and 0, that is fine. And then node 1, we want it to be at 490 and then 285 as per the manual. I got it from here. And then node 2, we want it to be at 150 and 240. Okay, let's change that as well. So we want the node 2 to be at 150 and 240. Good. So we have done that change as well, which is indicated here. And then we want to write this function that will be recursively called to capture the TCP congestion window sizes that have been used. So we need to place it here. Yeah, it should be here. So let's try to do a cut and paste. We'll have to be a bit careful. So we'll copy this. Sorry, not in application. We want it to be in agent definition. So let me try it. Control C, Control B. Good. So we have got it the way we want. One thing we should note is this TCP agent. So is this the TCP agent that we are using? Yes. Our TCP agent also is TCP0. So we'll leave it like this. The rest all seem to be fine. And after that, we should close the congestion window file that we have created in the finish function. So we'll get into the finish function. The handle we have used is congestion window file. And then we will close it here. Close $congestion window file. Good. So we have, I think we are done with the changes that are required. Now let's go and try to compile it. And let's see if everything is fine. Good. It has gone through and it has also started the NAM. So that means all our edits that we did are good. So let's maximize this now. And okay, we got 0 at the 0 node 1, sorry, node 0, node 1, node 2 at the locations that have been specified. And we had defined this to be mobile and this also to be mobile with certain velocities. Let's say, and we had defined them to be moving after 10 or 12 seconds. Anyway, we have started it now. So we can see the time ticking. Let's increase the step size so that we can play it in a bit faster mode. Yeah, now we can see that 0 and 1 also have started moving, but they are not in the radio range now. So now we can see they have got into the radio range, and AODV routing protocol is kicking in, and we can see that 2 is being used. Those 0 and 1 were initially not in radio range. They found out that 2 can help them, and they are using 2 for the package to move from 0 to 1. That is how it is happening. Good. So this is how, this is the first time we are seeing how the radio or the wireless network scenario operates when mobile phones are moving or the mobile devices are moving, and only when they get into the radio ranges, the communications have started happening, or TCP has been established, connection has been established, and FTP data is flowing from one to the other. This is the first time we are seeing it. And we had set the routing protocol to be used as AODV. Well, we'll later see, next part we'll see that we'll change this routing protocol and see the difference. Okay, fine. So since we have seen it visually, now let's see what the statistics say. So for getting the statistics, we know we need to run the awk file, and remember now the trace file will be in a different format than the wired scenario. So that's the reason we are using the awk file, which is wireless awk file, written for the wireless trace file specifically. So we have this awk file written for us, experiment 08 AODV dot trace. Okay, good. So we can see that we have got this details here. So wireless scenario, we have all these acknowledgements transferred. Okay, fine. This is the TCP. You can see that there are approximately 3,400 packets that got exchanged. 7 of them dropped, out of them certain remaining delivered. So we have this ratio. Fine. And when we okay, when we run this awk file, it should have also generated the data files, throughput data files. Okay, we have got the throughput data files, GNU plot, and then to have a look at the throughput data files, we'll use the same throughput.p. This is how our throughput has increased over time. So in fact, though the simulation started at say 0th second, they were not in radio range 0 and 1. When they started moving, approximately 40th second, they came into radio range. By using 2 as a relay, they started communicating 0 and 1. That's how the throughput increased. And you can say it went on till approximately 145 seconds or so. And using this AODV, they were able to get a throughput up to, I think approximately, if you take this as the peak, it should be around 275 or so kbps, kilobits per second. Fine, that is what we can see from here. And then the other thing left is the congestion window. Let's see how the TCP managed the congestion window. And we had already saved it in the congestion window dat in the TCL. So here's the data file. So we need to plot it. So we'll use mgit congestion window plot.p, and let's see. Yes, this is how. Again, it is correlating with our understanding. After 40 seconds, they came into radio range, and that's where it figured out. In fact, all the while, it had a congestion window set to 1. That means it was just trying out, sending one packet at a time and seeing if it goes through. It was not going through. So after 40 seconds, approximately 42 or so, it realized that the packet acknowledgement came back. As soon as the acknowledgement came back, you can see it has started pipelining more of them now. So it increased the congestion window from stop and wait. It kind of now started pipelining to make use of the link effectively, and we can see it reached the peak till this point, and then again it went out of range. That's the reason it just again dropped back to stop and wait. And of course at 160 we stopped our simulation. That's the reason it stopped over here. Okay, this is what we can conclude. So we'll stop here, and in the next video we'll change the AODV protocol, routing protocol, and we'll use the next protocols that are there. That is the DSDV and DS. Okay, see you in the next video.